It's pretty cool because a team of field meteorologists, they placed themselves in the right place at the right time, right in the thick of last week's severe thunderstorm outbreak. They collected critical data about hail with that goal, as Dr. Knabb said, to potentially change how we manufacture cars and build structures to better withstand the power of destructive hail. So I want to bring in Dr. Giammanco, lead research meteorologist for the Insurance Institute for Business and Home Safety. Let's talk a little bit about what you did last week and the goal of this project.
Yeah, hey, Alex, glad to join you guys. Our project really is focused on, as Rick mentioned, understanding the characteristics of hailstones themselves, their shape, how strong they are, but we're also using instruments to map really how many hailstones fall within them. So we're trying to get an MRI picture. And by doing that, we place instruments in front of the hail-producing thunderstorms and allow the hail to fall on it. And we get to see, one, how many hailstones fell per square foot, how big were they, what was that size distribution, and get a really complete picture of hail within that particular thunderstorm.
All right, so you're putting yourself in the path of a hailstorm. It's not the easiest thing to do, right? Like, what's your success ratio here? Because you got to be at the right place at the right time, and you actually have to get a storm that produces hail, right?
Yeah, Mike, that's right. You know, we give ourselves about 40 minutes of lead time or so to get our instruments down. But the key is to try to find the storm and predict what it's going to happen in 40 minutes or so and get the teams in the right spot. So we've had quite a bit of success over the years doing this. But again, sometimes the storms don't cooperate, don't do what you think they're going to do, and you're left kind of empty-handed from a data perspective. But you learn as you go and kind of refine those deployment strategies. And we've done pretty good. And I think last week we pulled that off pretty well.
Ian, give us some more details on how you utilize, collecting hailstones in the field and then scanning them and then 3D printing them and, learning about the sizes and shapes. How does that all eventually translate into our roofs and structures being more safe?
Yeah, so I'll give you two examples. We'll start with 3D scanning. That gives us that really accurate three-dimensional picture of a hailstone. We can apply that to understand the aerodynamics of that particular hailstone and really all those like it or unlike it to know, one, how fast do the things fall? And that in turn leads to how much energy they have when they hit things like our cars and our houses. So we can apply that in the lab and have very accurate, essentially impact energies in which we propel our laboratory hailstones. The second piece of the puzzle is understanding the strength of those hailstones. So we do crush tests to determine how much force it takes to break them. We can then tune a system we've developed here in the lab to actually produce ice that mimics those same properties. And that's the laboratory manufactured hailstones we propel at building products and ultimately lead to our shingle impact ratings and really any applications where we're looking to improve how we build against this particular hazard.
So somebody watching at home going, wow, 3D printing and going out and mapping, MRIing this thunderstorm, ultimately you hope to lead to better savings or prevention of loss for people in terms of cars and homes.
That's right, Alex. People don't realize, any given year, 60 to 80% of the damage from severe thunderstorms is hail related. So one, it's a hazard we don't build with in our mind. So we need better roofing products. That's your first line of defense. And then we got to work our way through how we deal with siding, windows, and those other things like your HVAC systems. And we got to start building with this particular peril in mind to try to drive down, one, the losses, but also the annoyance factor. For any of you who had to have your roof replaced due to hail, and many of you say in Dallas or Oklahoma City, you might be on your third or fourth roof in the last 5 to 8 years or so. We know how annoying that is, and we want to get better products on homes.
This is really cool. Dr. Ian Giammanco, lead research meteorologist for IBHS. We thank you, as always, for your time, for joining us, telling us about this project, and we look forward to talking to you again in the future.